Hello, everybody, and welcome back to stage 2 of the Diana Initiative Virtual Conference. Woo! A quick announcement for y'all. The Career Village has a raffle for some eLearn security courses. So please remember to stop in or to enter. It is in the sessions area. Today we are going to be hearing from Aditi Bhatnagar. She is a security enthusiast who is presently working as a software engineer in endpoint security, developing Defender solutions for Android at Microsoft. She is currently involved in researching the privacy and security aspects of the evolving Android landscape and likes hacking around with tools and technologies that interest her. Intrigued by the numerous ways in which technology is shaping human lives and societies, she likes researching the evolving relationship between the two and to share her perspective on her website, Digitize. She is an advocate of digital privacy, security, and digital well-being, and has conducted several talks and workshops to spread awareness regarding the same. Please join me in welcoming Aditi. Woo-hoo!
Thanks, Josh, for the introduction. Yeah, hi folks, I'm Aditi. First of all, thank you, Diana Initiative, for offering such an amazing platform and giving me the opportunity to talk. And it was really awesome to see all of you in real time, but never mind, we will do a decent job here in network after this. So so the topic for today is really interesting, hacking into Android apps. Disclaimer, first thing first, it's my opinion and not of my employers, essentially. And one of the good things about the talk is that it's happening at a really good time. For the last, in the recent times, Microsoft has announced support for different platforms like Linux, Android, iOS. We are taking Microsoft Defender to the other platforms. So and I'm working on the Android thing, and it's very exciting for me to talk on this particular topic here. So let's talk about Android. So before jumping into the technical details, let's talk a little bit about the market study, because it's very interesting when it comes to Android and creating Defender solutions for Android. I'm hoping a lot of us who are on this call right now and will be watching this might have used Android already, because we have like 2.5 billion devices, more than 2.5 billion devices active there. And if you look at the distribution, it's very diverse. So it's like Android 1.5, Android till Android 10, and now Android 11 is coming up. And there are a lot of devices which are active not just on Android 10, but also on 9 and 8 and lower than that. So yeah, it'd be a good thing to know which one do you have. So oftentimes when I ask this question, especially in the non-tech forums, people are usually not aware of it. So it's a good show of hands kind of question, so that you get to know in the audience how many are Android fans there. And the market distribution, as we say, it's like a segmented market. And why it's important is that it offers a very unique problem to solve when it comes to defending it, because people are there on different platforms. So it's not a clear-cut thing that, okay, build this thing in this one. You don't know how many people use the previous platforms. You have to build the solution in such a way that those platforms are protected as well. And to top that, Android is not just in one particular OEM, right? It doesn't only ships with Pixel. It comes it's open to anyone to adopt. So there are we have different OEMs. We have Samsung, Oppo, Motorola, all of them on Android. And what happens is that they add their own OEM specific layer on top of it. So that also adds different kind of things to the design, which offer different set of challenges. Because oftentimes it can happen that even if the bugs is not in Android, there is some vulnerabilities on that extra layer which are exploited and targeted for that OEM specific person, OEM specific device. So let's talk about the security patches thing. Again, this is one interesting thing. It's always recommended that you keep on updating your Android mobiles, because the security patches are supported only for so much time. So it's like fixed number of years, and after that the support is not there. So a lot of people who are still on the older versions are still vulnerable, and there's nothing much that you can do in that domain. So that offers another challenge in defending Android ecosystem. So these are just slides showing the numbers of some supports, which I pulled up from the links from the vendors. So these are the challenges, and this is how the overall segmentation looks like. And let's talk about the Android threat landscape now, having talked about the segmentation. So since when have we started seeing Android and how it has evolved over years? So we'll talk from 2010 because the numbers was really low at that time. And then from there, it has just boomed. So in 2010, the numbers were around 26 plus 4. Major vectors has been around side loading from arbitrary websites. So if you don't go to the recommended source to download, you're not going to Play Store to download, which is trustworthy. If you're downloading it from some website or side loading it, there are there are very high chances that it is a vulnerable. It can be a potential exploit. So and a lot of these have come through those channels. So back then in time, it was like premium SMS trojans and spywares that were popular. Then we see that towards 2011, we started getting routing trojans. Then we started getting spywares and adwares around 2012. In 2013, there was a hit in financial malware, banking malware, premium SMS, which went really viral in amongst the researchers. And then 2014, it was again the same set of things, but the number is higher. And it goes on and on and on. In 2015, the firmware level of things started getting exploited. So that was there. And what's interesting, in 2018, we started having coin miners, leading to the Bitcoin adoption and mining thing. We'll talk about it a little bit in a little bit. So that is the evolution and keeps on happening across the years. And how do they infect? Essentially, as we talked about, the third-party app stores driven by downloads. You go to a website, you just downloaded some APK file, and you mistakenly installed it. Side loading, Trojanized apps. The apps look good, but then they're doing some malicious things in the background through either knowingly or unknowingly. They might have third-party libraries which are doing it, or they themselves do it. So that is there. Then firmware Trojans. Aggressive ads, hijackers, and sometimes it happens that even in the official store, the app was malicious, and then it is caught later and removed from the store. So those are the infection channels. This is again some basic stats to get that overview right. The 2020 thing is still growing, so it's just August 21st, where we are sitting on 2.28 million of Android malwares and 2.48 million of PUA. PUA stands for potentially unwanted apps. So what are some prominent attacks in Android? Like what, if you think about it, what all can you do from Android? So one thing that you have to keep in mind in studying all these attacks is that it's a very personal thing. It's your own device. So a lot of personal information can be there. So when it comes to spying, for whatever reasons, Android makes a good platform to be exploited to the hackers. Similarly, it's like the breadth of things is a lot. So there are a lot of devices now that gets involved in when you have, say, DDoS attack or botnet kind of thing, because the number of devices that we have is huge. So those are the things that come when we talk about the prominent attacks here. So talking about banking malware is essentially, as the name looks like, it is something which is doing fraudulent transactions. So basically, it takes your credentials and then does a transaction from your end. And how it exactly did it back in time? So it started a malicious demo service and silently monitors all the apps that victim opens. So back then we had this permission in Android where you can get all the current permissions, which all the current applications which are active, which the person is looking at. So you can get the exact app that the person is looking at. And then what this malware did was put up a prompt on top of that app, asking for, suppose, your credit card details or whatever. So it looks like, from the user perspective, it looks like it's coming from the app, because as a user, you have no clue that there's a background service which is popping up this particular thing. So that used to happen, but then there's a question that how was the two-factor authentication handled? Because it's not just me entering the credentials. You need another factor as well. So for that, they added access to the SMS permission. SMS storage. They were able to read the SMS. They also deleted the SMS once they have read the value. For the cases where the OTP or two-factor authentication was coming through voice calls, they added a forwarding service by using USSD codes and then getting the OTP. So those kind of things happen, and additional things that were interested there was like they added this code to neuter all the calls if the victim is trying to contact the helpline. So even that won't go away. So it's like, what all you can imagine a simple app sitting on your Android can do, to try to use all those things to get fraudulent transactions from victims' behalf. So, and even the incoming alerts were muted. And this was actually a very big thing. A 25 million USD heist happened because of this malware. And here is something that I recreated on the basis of how basically it worked. So if you can see, I'll just fast forward it because I didn't speak it out. But if you see the list of this, com.android vending, this is basically the package name. So every app sitting on your device has a unique package name, and it gives all the package names that you have to listen to. So here what happened was like, I'm listening to com.whatsapp, one of the package names. And when I click on WhatsApp, after some time, you see this prompt comes up on top of it. So you'll see that enter your credentials, Google Play, card number, some things I filled in. So this is basically now it looks like, WhatsApp is asking me, and suppose it's not WhatsApp, but it's some paid service, some paid game or something, it'll appear very genuine. And there are high chances that the user will end up entering the credentials here. So this was a basic way in which it was used to harvest the credentials. Then let's talk about ransomware, a very popular term in InfoSec. There are usually two types of ransomware. One is crypto ransomware, the one is locker ransomware. Crypto is the one which encrypts your whole data sitting on the device, and then hides the key or asks money in return of the key. The locker ransomware is the one which basically comes on top of the screen, making the user the user just cannot do anything, not letting the person operate on the device. So it just is there on top of the screen and you cannot do anything there. So it's kind of locker ransomware. And the second kind is very popular in Android. How does it get on your phone? Again, through downloading contents and some social engineering tricks. This kind of thing is kind of common, so we can go past it. But yeah, one interesting case here was like the Boing app case. So now it's interesting how they play with the psychology of the users. So what this particular ransomware did was it came on top of the screen and then it told users that you have accessed some links or you have viewed illegal content and you have to pay money. So it's like your police is charging money, and again, like buying into that thing, a user ended up paying money on that. So here is one demo on how ransomware usually looks on Android. So this is censored app is the demo app. So here it's like this is a screen where it's asking for some money. I mean, pay here, Bitcoin or wallet address is usually provided, and then you do the transaction and give some code. And until you do it, it just keeps on appearing. No matter whether you go back, you restart the device, or you try different ways of getting out of it, it's just stuck there. So that is what it looks like. Let's go to the next thing, which is coin miner. So again, like coin mining needs a lot of compute, and hackers have already realized it for obvious reasons. So they have distributed the thing. So it's like there are apps on your device which are trying to do heavy processing jobs and leading to mining coins. And rather than the device owner getting the money, it just gets transferred to the Bitcoin of the hacker. So that happens in coin mining. It happens sometimes through apps. Other times it happens even through JavaScript libraries. Most of the things I think in this area is fixed. So JavaScript libraries, it's like you're accessing a web page, and through that web page itself, it is performing the mining jobs. So why do you care? Because in some cases it's illegal, depends. Then your compute power is exploited. Mobile is already limited resource thing, and if you perform high intensive job, it will be exploited, and you cannot use basically that power for your own wallet needs. And eventually the device will wear and tear fast, and you would need to replace the hardware. So it is a concerning thing. Another kind of things that we have seen is surveillanceware. As we talked about privacy on Android, there are like a lot of cases of spywares being used for different reasons. So surveillanceware, one interesting one which I read about, it's a report by Lookout. It is mobile surveillanceware, and it was kind of doing everything it could have done to get maximum details. So there are like things like remounting the system partition to install attacker certificate, or keylogger, obviously, making calls, recording calls. Then location is a very interesting factor when it comes to Android, retrieving browser history. Another interesting thing was like all the very popular dictionary terms. So whatever you type on your keyboard, which is a common thing across all the apps, it was able to get a dictionary of all the popular, frequently typed terms, and then know what the person is talking about. Similarly, taking screenshots or taking photos. So that is about surveillance ware, and a less intrusive version of that is a stalker ware, which is usually found misused in domestic violence. And in fact, nowadays there are like a lot of apps which are coming up for tracking children in a school or different ways. I think there are a lot of ethical debates and privacy rights involved there that need to be discussed, and this issue is still open there. Another thing is phishing attacks. Now, what's interesting in phishing attacks is that it's a lot of user context is involved in phishing attacks. So I'll share a brief story about an auto guy. So for those who don't know what an auto is basically a very popular, so I am speaking from India, and here it's like a popular transport vehicle. It has 3 wheels and pretty affordable. So we have like a whole set of people who earn low incomes, and they have taken up the auto driving profession. So I was using that transportation mode to go somewhere, and I asked the person to just stop and let me collect my parcels, which were coming from some e-commerce sites. So the person asked me that, he asked it in Hindi, of course, but he asked that, ma'am, is it okay if I buy this thing from, say, a particular website? And it was a very renowned website, so I said, yeah, of course, you can go ahead and buy it. But then he said that it's like a 17K mobile that he's getting in 4K. And then I got suspicious. I was like, where did you get the information from? And he showed me a popular chat app, and there was like a proper group created with a profile pic changed to that company's logo, and there were like a lot of schemes going in there, and the URL was just exactly the same as the original company's URL, but just one extra character added. So now here the problem comes of not just tech literacy, but also English is not the native language of that person. The person won't know the spelling of it. It's very fair to assume. And that way, if you're asking the person to remember that, because for those who are fluent in a particular language, it's fine. But if you're not, then remembering it's a different task. And their assumptions can roll in more. So that was a thought-provoking thing for myself. And already it's like the person is earning low, and then they're exploited more on the tech literacy basis. So it's a very interesting point that we have the Android outreach to a lot of people, but not all of them are have that digital literacy which is needed. So apart from the industry giving the solutions, this thing should be addressed from user perspective, was the thought that I had. So having talked about all of that, let's get into the most exciting part, which is reversing Android apps. So I'm assuming that we don't know anything about Android. So we'll do a quick walkthrough through what an app is, how it looks like, and what all is there, and the platform architecture. So Android apps are usually coded in Java and Kotlin, and as you know, Java, it compiles to bytecode. The platform structure architecture looks like this. We have the app sitting on the top, then we have Java API framework. Then the interesting thing is that we can also add C and C++ code in the same Android app. So there's a thing, JNI, which is used to interface both of them so that they work together. And we have Android runtime and hardware layer, and then towards the lowest thing, we have the Linux kernel, SE Linux. So that is how it looks like. The architecture and everything is sandboxed. So every app has its own UID and group ID. Every app has its own files is stored in a particular location which is not accessible to the other file. The permissions are handled in a very interesting way, which I was reading last. So it's like you have, in the end, you have like group IDs the same way it happens in Linux, but how the permission from Java gets all the way to the kernel was interesting to know. So it's like end up in group ID. I think what will be interesting to study here would be with the revamped permission model, how does that file basically changes. So yeah, typical components of the app is, app is not exactly a process. An app can be triggered or brought into the background, into the foreground through a lot of ways. So we have activity. So whenever you use an app, whatever comes on your screen is an activity, can be treated as an activity. So every new screen, for starters, you can assume that, okay, it is an activity. There are more details to it, but for the first understanding, we can have that assumption. Then service is something which is already always running in the background. and doing jobs. Just like in our banking malware, it was showing up a pop-up, right? So it was a service which is running in background, looking at what is happening in the foreground, and then popping up that dialog box. Then we have receivers, which is broadcast receiver. Basically, if the internet has gone, the apps need to know, right? If internet is not available or if a Wi-Fi is available, I can do a download. So app needs all that information, and it comes to the app in the form of system broadcasts. So a battery has been plugged in, or the internet has changed. So those kind of things come in a receiver. You can put receivers for a lot of things. A new app got installed, etc. Content provider is essentially sharing information within the app and across the app. It can be files or database or whatever needs to be shared. So those are the components, and this file is the most interesting, the right one, which is the manifest. So whenever you reverse, this is the first thing I do. I just look at the manifest because it has all the major things. It has the application structure. It has listed all the permissions that the app is using, which gives you good clues into what the app is intending to do or where all it will affect potentially. It has all the different components defined within application tags. So we have provider, receiver, service, and activity, and there are many more things to it. These are just for starting up. And briefly about how the project is arranged. Basic folders, we have manifest, we have all the Java files in Java. Apart from the codes, we also have resources. So we'll have things like your layout designs, which are in XML, your images or media that you have included, which is again in resources. You can add things explicitly in assets. And then overall, in the end, towards the end, you'll have Gradle scripts to have this all compiled and running. So yeah, so that is the basic project structure. And once you've coded the app and built the app, then what happens? Again, quickly walking through it because it'll help when you talk about the reversing of the inward app. So you have application resources which are compiled using AAPT, so and gets into compiled resources. You have the main code files which are compiled into .class files using Java compiler, and then you use Dex to compile it into .dex file. And then you have EIDL files as well in the apps which actually use Android interface definition language, but usually they are in normal apps are not seeing them. So all of them get compiled into the resources, and then you have APK builder, which produces a single APK which has all of these there, and then you further have a jar signer to sign that APK, and zip align finally release the APK. So that is how the whole build process goes in general. The interesting thing is that Java, just putting it again, it's like not platform dependent, right? So that gives a lot of ease while reversing, because if it's a C thing, it's like directly compiled into a platform specific thing. In Java, you have bytecode, which is comparatively more readable when it comes to disassembling and seeing it. So you coded the app and built next. Okay, this is the same thing basically. So we just talked about it, and we talked about how it's relatively easy than reversing the native apps. So let's go in reverse. So what I have done here is that it is a sample app, sample APK which I created, and I'm putting it into the app. Now we have built the app, we have put it in the app in the Android, right? Now what I'm trying to do is pull this APK and see what all is there in the APK. So basically there are tools to do that. Here I have installed it. So this is the app. There's a person meditating. And now I'll pull it. So there are commands for that. ADB is very interesting thing whenever you come to Android. It is Android debug bridge, and it has a lot of power. So if you are connected to ADB, you can do whatnot. You can screen record, you can execute a lot of commands. It's really interesting. Whenever I read more about it, I get something new. So ADB is a really interesting thing to me still, and there are ADB commands to do the same, to pull the APK. So when we do ADB shell, we basically get into the shell of that emulator. So I'm running this in emulator, and once I get into the shell, I can check for the path of that particular app. So we use package names. So I put ADB shell pm path and the package name. That returns me the path of the package. So it's basically the exact location where the package is living on the device. And then what you do is ADB pull and give the path. So once you have done it, Yeah, so here I've pulled it, right? And then the thing about APK is it's just a zipped thing, basically. So when you unzip it, you see a lot of things. So I did unzip base.apk. Base.apk is a file that I pulled out of the system. And what I see is that this particular view, right? So you see Android manifest.xml. You see base.apk. Oh, that was already there in the directory. Please ignore it. There are classes or decks, which are the bytecodes, Talvik bytecodes, and then you have resources and some other properties associated with it. So this simple information you can get just by pulling out the APK and then unzipping it. That is the first thing. And then we still have decks, right? So we don't see the code yet. So how can we see the code? There are decompilers. JetX is one of the best open free tool, I'd say free tool. And it actually does a lot of decompiling. So you can see that what I've done here is that is the JetX GUI. I just put the APK file here, which I pulled in the last slide, and it will decompile. It will get decompiled and you can actually see the whole Java code. So it's as simple as that. If there is no obfuscation and if the code is fairly simple, just like the app I coded. So yeah, it's like properly uh, coded thing that you can read through. You have all the things, resources and everything. So basically the whole project structure which we just went through gets created by putting the APK in this JetX GUI. But there are things when JetX will fail to decompile properly, then what do you do? So there are a lot of different tools. We are just talking about a few of them in this talk, but we can then check the tools at disassembly level, which is basically Smalley, and Paxmolly is a disassembler. So we can use Paxmolly and see what is happening. It is not as readable as this Java file, but it is still manageable and it has much better details and things. So let's talk about Paxmolly a little bit because it's interesting. So to the right, what you see is a snippet of how Paxmolly code looks like. Things might look a little weird here, but it's kind of, you'll get a hang of it looking at it. It's doing basic things. Like you're defining variables, you're defining parameters, and then you are assigning values, basically calling functions and stuff. So a clear mapping of it is available on web. There are a lot of amazing resources where we can see what an exact Java function will get mapped to in Paxmolly and for in Smalley code. And for I think our purpose, our app is fairly straightforward, so we should be able to learn things from that Smalley code. So here, this is another thing where we'll be talking about Paxmolly. So having done the JetX, where we decompiled the app and saw the contents, we now want to know more about it. So what all can we do from Smalley level, not just the JetX thing. So here, it's an APK again. Let's see, and let's walk through the demo, and I'll just add information as we go. So I installed the APK. I installed here. This is the app. This is the app, which is the truth. So when I do get status, it says the world is recovering from pandemic situation, which is the truth. So this is the nature of the app. It just, when I click on a button, it gives me a dialog saying the world is recovering from the pandemic situation. Now I'll use APK tool, which is another tool available out there to do this decompiling. It supports a lot of different things. Paxmolly thing is one of that. So it can decompile your APK and it outputs it. This is what we are doing in this command. We are decompiling, decoding the APK and putting the output in out APK folder. So this is the file which got generated from that command using APK tool. And now this is a Paxmolly code, right? So if you see, it is like methods are defined, different methods are defined, static constructors. B here is basically the void, the return type. And you have different invoke, direct, and different kind of commands to do certain kind of things. So if you look at it, you can make sense of it. So see, the world is recovering from pandemic situation. This is the one string which it is returning. We're not doing very major thing here. That is not the planned goal of this demo, but we want to do some change. So we want to tweak the behavior by changing the code and then see how it looks like. And we have to do this tweaking in the small code. So that is the goal. So we find out where is the string which is being returned to us, and I want to do a change there. Okay. Just give me a second. I think something went wrong here. So this is the string that was returned, and I thought, let me just change it and put that, which it is as easy to patch this code that we're doing. So when I do this and I do apk2 b out apk, which is a folder which is having this. So we get the APK back. I've done the change, so we get the APK back. But the point is that it is still unsigned because we have just patched it. So we need to sign it. And then there are a lot of jar signers available, which you can use to sign the APK. Anyone can sign the APK until it's trying to update the same file, I think. So yeah, so you can create your own signatures. And I signed the APK then. And now I'll try to install it. So after resigning, when I go and I have to uninstall the previous app, and then I'll install the new app. And then when I go now and click at it, you'll see that the string has changed. So kudos, that was first small hack into backsmally. The more I think you look at the code, you'll get more understanding. That's something that I am myself working on. But yeah, it's fun to see this thing working eventually. Okay. So that was another demo on how backsmally works. And then comes Frida, which is another very interesting thing that I am excited about these days a lot. So which is essentially altering the code dynamically. So what we did just now was statically altering the code, right? We just changed the code and then it got changed. But what happens in Frida is like next level. And Frida is available for a lot of platforms. I was trying out for Android. In Android also there's a lot of functionalities which I haven't explored yet. But this is the basic thing which I did. So I'm hoping like a lot of you would have heard or experimented with it. So I tried for Android, and in Android it's like a client server model kind of thing. So you start a server in the emulator or the device so that you can connect with it and give commands to it. So we install a Frida server. We go to the Frida site. We install Frida server. We set it up. Giving these permissions. So it's like well documented online. But apart from that, you also need to do some setup on the laptop on which you're doing. So once you have set up the emulator or device with the Frida server, you go to the laptop and then you basically install Frida platform tools. So Frida platform tools are needed to communicate to the server, which is already there in the client. And you can check whether the connection has been established or not between the two using Frida PS -u command. So it will tell you whether your server is able to communicate. And once the connection has happened, boom, you can do a lot of things now. Let's see what.
Yeah. I'm giving you your 15-minute warning. I'll get off the stage.
Cool, thank you so much. So so that is there. We have established the server and client thing. Now this is a cool app. We would have heard about biometric, right? Like you basically in Android you have that fingerprint sensor now which can use to unlock. So I tried experimenting with that, and basically can I get into the app even if my biometric thing has not passed using Frida? So this is a small hack for that. So what we do here is that the first thing that I've done is see that the emulator is having Frida server. So I've done all the steps in the previous slide. I installed Frida into the device and I gave it the right executional, right permissions to execute, and then I run the server. And once I have set up the server, I check on the system whether I'm able to do that Frida PSU command. So basically this will return all the active processes on your emulator or device, and I'm seeing a list of them as I run that. There we go. So once we have all the processes, let's start writing something. So Frida allows of dynamic injection into the app code. So basically you can dynamically change the execution flow of a particular method. So you're not actually changing the app code itself, but you are injecting some extra script that you want to run instead of the code that app is running. So what we do here is that I'm trying to create a script here, as you can see in the first terminal on top. So what we are first doing is we import Frida, then we do device frida.getDevice. So basically, when you do ADB devices, you see all the devices connected. So the get device, the argument to get device is one of the devices that you want to establish the session with. So once you have the device, then you establish a session. On that device, which app do you want to hook to? Because you need to provide that, right? So this particular app name is what I have provided in device.attach, line number 4. And then we check that the session is established. Now it's time to write the script. So the script is in JavaScript, which is eventually converted and injected by Frida. So what the JavaScript is trying to do here is, what I did was basically hooking on to the callbacks. So we get the method name, which we want to change, and then we change the name of that, the function of that method. So let me pause here 1 second. Okay, so this is the JavaScript. Function hook is the function that we want to perform, dynamically load. And inside that function, what I'm doing is, first of all, getting the class. Where CLS class is basically in the app. So you need to have basic information about how the app is structured, so that we can get using JetX that we just talked about. Get the APK, see what classes are there. And you'll get a basic insight of how the activities are and which activity will have the method of your interest, right? So once you have figured that out, you put the class in that, and you put the class on authentication field is basically the method name, and then dot implementation is call success. So call success is a JavaScript function. So in this CLS on authentication field dot implementation, now I can put in my own implementation. That's what the line is trying to do. So what we do now is that we have added the JavaScript. We create the script using session.createScript. And now the only thing which is left is load the script. But before loading, let's see the behavior of the app to know that, okay, it worked, right? So what the app is, it's a bank app, and it says authenticate to login. And whenever I click on authenticate to login, it's because it's an emulator. There are like different fingers set up for the login. Finger 1 is the actual code, and all the other fingers are basically false code. So when I touch the sensor using finger 5, it's saying not login. And in bank, you cannot sign in. You cannot see eventually what's your bank account details, right? But when I click on finger 1, it will log in and show me the bank screen. So this is what is happening before injecting the script. We have just created the script right now in Frida. And now let's load the script in Frida. So once I run this command, the script is loaded. So now the behavior of the app it'll reflect. It has dynamically changed to take up that script into action. So now when I do login and I go to finger 5 and I do touch sensor, boom. Don't look at the login not recognized. Look at the backend, right? So this activity has changed. It's like the actual activity which had the bank details has come up, and we have successfully bypassed the authentication. What I've done here is basically not hooking into the biometric details of the system, because it's very much hardware specific. I was interested in the callbacks that I get. So because whenever it's successful, I'll get a callback on success, on authentication successful, and if it is failed, I get on authentication failed. So what I've done in the JavaScript is that even on the callback of failed, I call the successful method. So whatever happens when I get a success is what I'm doing when I get a failure callback while putting finger 5. So that was the small demo on Frida. It's like an amazing tool, and there's so much to explore, which is in my to-do list as well. So and if you have ideas, let's do it. So it's really awesome. I like it. So I talked about the dynamic altering of the code. This is again briefly touching upon what kind of different securities and vulnerability issues are there. So one of that which we saw was like code tampering or reverse engineering, which we just touched upon. There are a lot of different things. The first one is like improper platform usage. So we provided you methods for doing A, but you are doing everything apart from it, right? So you're misusing the method basically. And this is another interesting demo that I created on Strandhog vulnerability. So it was revealed by Pramon in December 2019. And I read this study pretty detailed, and I tried to create it up on my own. So what happens in this is there's a concept of task affinities. Okay, let me brief you. I think, yeah, it should be doable. So I'll take 1 minute and brief you on task affinities. All of us use chat apps, right? I think WhatsApp or whatever chat app you use. So whenever you go and click on add phone, add contact, you'll see that the phone contact screen occurs on top of WhatsApp. Right, so it's like it's basically a single task, and all of these screens get stacked on top of each other. So when we say add contacts, it doesn't take you to the contacts app. It's actually building on top of WhatsApp app because there are task affinities defined. So now if you don't add the contact and close the app, but when you still click on WhatsApp without like destroying the app, if you click on WhatsApp, you'll see the contact screen. So basically they keep a stack of which one is the top activity and which different app is it referring to, right? I could have drawn it on a whiteboard. Never mind. But I hope it's clear. So let's see, and then maybe I'll add a little bit more details. So what's happening in this demo is there's an app that I created. I called System Support so that it's convincing. And then we have another app, which is Katana. So it's like Facebook. Now what is happening here is, if you notice, what do you expect when you click on Facebook? That Facebook will open up, right? But here, if I'm clicking on Facebook, I first open my System Support app, which is this view, which is sign in, email, password. Imagine it in your mind that it's looking like Facebook, because I really couldn't get the time to fake that page. But imagine it's looking like Facebook. And now when you go to Facebook, it is actually opening that app, right? So this is happening because of task affinity, and it's an open and doable thing. And it's being exploited. So if you see, it's like a different kind of phishing, a very platform-specific phishing that you click on an app, and then my app comes up, and it looks like Facebook. Don't go by the app name. I'm not very interested on that. But yeah, it basically looks like that, and it can ask you a lot of permissions, right? It will ask all the permissions, send your data, do whatever malicious act it wants to do, and then it will again target you back to the original app, and you will have no clue. So they have a really nice video put up online where this is actually happening, and they're able to harvest all the credentials, and users are clueless. Cool. I think we are running short on time. I'm just sharing my excitement on Android 11, which is being rolled out. There are a lot of cool privacy security features introduced, like scope storage, revamped permissions, location sharing, and a lot more. So that's all I had. Yeah, and if you have any questions or doubts, or you want to have a chat after this or right now, please ping me. I'll be available. I'll be around. So yeah, that's all. Thank you so much for listening.
Wow. Holy crud. That was amazing. There's so much in there. You do have a few questions from the chat. Let me read those here. So Vineet asks, does like passwordless access to a device help you break into your devices?
Sorry, I didn't get you, Josh.
Oh, I'm sorry. Can you hear me?
Yeah, I didn't get what access exactly.
Oh, so does passwordless access, like passwordless turned on in Android, does that help or hinder an attacker?
Yeah, I think it can, for sure. I mean, you can automate a lot of things. If you have a list of passwords, yeah, you can go ahead and try out. I still didn't get the sense of it. So if there's more context, maybe I can add. But if what I understand is right, yes, definitely it can help.
Got it.
And we have a really amazing thing in Android, which is accessibility service, which can automate a lot of things. So yeah, if you have that permission, you can do whatever you want on Android. It's like super powerful.
Got it. Vineet, if you wanted to add more context in the chat, I will grab it. Next question. Alyssa asks, do these Android ransomware samples also attempt to spread, like worming, such as through phishing a victim's contacts, or are they typically single infections?
So typically single infection, because it's like once they don't perform any act, that is what was seen, that once they have locked, they are not functioning anything, and they're not letting the user do anything. So it's usually targeted, is what I've seen.
Got it. And Brianna asks, a lot of people use open source app stores such as F-Droid. How do you balance a desire for an open ecosystem with the risks associated with it?
What I do is actually reverse CFK before I install something. So because there's a lot of risk, of course. But one thing, basic thing to do would be like the permissions that it's asking and the utility of it. It's a very basic check. Like someone is asking, some app is asking a lot of permissions. It's not even using. It's like a clear indicator that something is going wrong. And honestly, like one thing would be like you cannot trust. It's as equivalent to installing, downloading executables from unknown sources on web. It's like the comparison is the same. So don't trust. Check for permissions. Reverse engineer if you want to. Yeah.
Cool. That was all the questions I had. Thank you so much, Aditi. That talk was amazing. And let's have a round of applause, virtual round of applause. Woohoo! All right. Thank you so much, and have a great rest of your day, audience and Aditi. Yeah, we'll sign off.
Yeah. Bye-bye.